Hello, Nabon Savin Avelin. Welcome. Hiche basic math series adenga last topic vectors na. Hiche hi involved hintin. Vector chapter hi sawin na video khat bo si boldi katia le chun pungkal khalang lu ding hin. Hiche acho video niya involved. So this is the first part of vectors. Okay. So let's jump right into vectors. In physics, okay, so we have something called physical quantity. So what is a physical quantity? Simple ta say dinga cho physics are terms nan sim deu zo si na definition na sim deu zo si ho he cho zo si ho physical quantity ki ti cho definition cha chu pyam tele. So it is a property of a material, right? So it's a property so which can be measured. Now first thing, you can measure it and then you can express that measurement, that value as some numerical value along with some unit. Now for example, if I say mass, so mass is let's say 5 kg. Mass so 5 kg ka tiala 5 so numerical value is a kg to unit chala na abana mass ki tiang ke measure thai chala na. So something that you can measure and express it, okay, that is a physical quantity. So like I told you, in a simple language, in simple words, it is everything that you're going to learn in physics. So everything that you're going to learn in physics can be classified into two types. Scalar quantity to vector quantity. Okay. So what are scalar quantity? So if a physical quantity has only a numerical value, okay, it can be described by, so if it can be described by only a numerical value, hichi numerical value zong hi magnitude zong kiti cho che na magnitude bo si na described here le depend to scalar quantity. For example, mass. Okay, so example mass katile, suppose if I want to say mass of something, I should say 5 kg 10 kg na chela 5 10 kiti pa ko magnitude numerical value kg pa as an unit times na. So any physical quantity that can be described using only magnitude, okay, by only magnitude, that is called scalar. So what about vector? So any physical quantity that can be described by number 1 magnitude and ngai. Okay, number 2 behind number 2 so magnitude q se hilawa to hai direction jong na. If so direction is also required. Okay, so if it has a magnitude and a direction as well, then that physical quantity is vector. So it is written like this in your books. Okay, but so only these two are not sufficient. Okay, so there is one more thing, so which is required in order for physical quantity to be a vector quantity. So what is that third? So the third is it should, okay, I'll just write here, it should also obey the vector law of addition. Okay, so three things: magnitude, it should have direction, and it should obey the vector law of addition. It's a vector law of addition. His addition in phala sim na. Okay, so see, why do I say a vector law of addition? So you all know current na. So I have a wire like this, say A, O, B, C. So let's say current from goes from A to O 3 ampere. Okay, and then from O to B, let's say it is 1 ampere. Now hotele O to C current is at GDM. So logically you can think you know that this should be 2 ampere. Nah. 3 ampere to 1 ampere to 2 ampere like home can. So see here, direction is important na. Current 2 ampere pa hi from O to C. Okay, it is going from O to C, not other way around. It is not going from C to O, it is going from O to C. So you can see that in current, direction is important, and it also has magnitude. But current is not a vector. Okay, Why? Because it does not obey the vector law of addition. Okay. So remember, current is a scalar quantity, not a vector, even though it has a magnitude and a direction. So some examples of vectors are so velocity, okay, displacement, and then you have force, okay, etc. Scalar example, you also have speed, you also have distance, etc. Speed jongko meter per second jula na, velocity jong meter per second jula. Okay, ba alaw na jo piham speed ju scalar hintin, velocity pa ju vector na. So when you write velocity, so the direction is important. You have to write along with the direction. Okay. Now basic difference between scalar and vector, that much. Okay, so now let's go into vectors. Okay. So first, how do you represent? Representation. So any vector, when you represent, so we usually draw a line, so like this. Okay, so first I'll draw a line, and then how do I write the name? So let's say this is a vector A. Okay, I will write any alphabet. So mostly we use alphabet, English alphabet, and above the alphabet you put an arrow, small arrow, like this. Okay, so we pronounce this as a bar. Okay, so you can also write, suppose I have like this. So from O to A. Okay, suppose a vector is going from O to A. So how do I write this? I can write this as OA bar. So if it is going in the opposite direction from A to O, I have to write this as AO bar. So AO bar means I'm going from A to 0 or A to O. So OA bar means I'm going from O to A. Okay, like that. So in English alphabet, and above the alphabet you put an arrow, small arrow. So that is how you represent the vector. Okay, so next. So how do you see? Suppose I have a XY coordinate Y. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so let's say I have a vector. I'll take 2 points here, P, and then here I'll write Q. Q at 5, P at 0. So if I go from P to Q, okay, if I go from P to Q, so there is a direction, and there is also a magnitude. Okay, so here the vector is PQ. I'm going from P to Q. So what is the magnitude of this vector? So when you say magnitude, okay, so simply it means the length of that vector. Okay, I'll simply write here length. Chila here length pa heavy relation P up at Q na chiva relation P to PQ is that 5 chila na chila heavy relation. So here the magnitude of vector PQ is 5. Magnitude so how do you write magnitude? So here magnitude of PQ vector, if I want to write magnitude, I have to put something called modulus. Okay, we call this modulus in mathematics. Now modulus of PQ is equals to 5. Okay, so modulus represents the magnitude. Now modulus so if I put minus 5 inside the modulus, okay, then the outcome will be 5. If I put minus x inside the modulus, I will have x. If I put 5 inside the modulus, I will have 5. If I put x inside the modulus, I will have x. Okay, so the purpose is modulus kiticho, so it will always give you a positive value. Okay, so why do we use modulus? Because the magnitude of a vector is always a positive value. Okay, this is why we use a modulus. Okay, so that much. So magnitude means basically the length of the vector. Okay, so we have done representation and then the magnitude. So next, angle between any two vector. Now suppose I have a vector A and I have another vector B. Okay, so let's say there is an angle of 60 degrees, right? So if I ask you what is the angle between these two vectors, So you will say 60, no? Because it is 60. So I have one vector like this, another vector like this, and angle between them is 60. Okay, so now if I give you another example, so I can also write like this: a bar, I have another vector b bar. Okay, so now you're given that this angle is 120. Okay, so now you're asked what is the angle between the two vectors. Is that item lang? Nah, vector a to small a to small b ka angle is adam. It is not 120. Okay, so here what you can do is you can produce this b. Okay, further. So now I will write here. So how much is this? So 180 is a straight line. Straight line to 180. So na 180 la so 120 the minus vala remaining to. That is the angle. So here this is 60. Okay. So here angle between A and B. Okay, A and B. So this is 60. So what is the condition here? So whenever you want to find the angle between two vectors, Hiche vector 10 hina. So it should always point outwards. Okay, so it has to point outward. Outward ka din should be ha. Chila hi velocity chila hi point of intersection tabang chila na ahong podo na hon. Hilai par velocity A zong hi outward, B zong hi outward. E vanga second case sa velocity hi chila ki so tu na jana chi A hi outward, hi vanga B pa hi inward. So B also has to be outward. Okay, so when you produce it like this, now B is pointing outwards. Okay, when both of them points outward, now you can take the angle between them. Okay, so this is how you find out the angle between any two vectors. Kutile aban to equality of vector. Vector ni chu iti phala ke bangdam if they have the same magnitude as well as same direction. Magnitude to direction jo ke ba la chon vector ni ke bangde. Okay, so just remember that suppose I have a vector a bar, so let's say the magnitude is 10. Okay, so suppose I have another vector pointing the same direction, b, so has 10 units. So then I can say that this a is equal to b. Okay, so both of them are same. Vector ni so only two things. They need to have same magnitude and they need to have the same direction. Okay. Okay, so moving on. So next you have negative vector. Now what happens when vector becomes negative? Suppose I have a vector a bar. Okay, it is pointing towards the positive x-axis. So what is, suppose let's say the magnitude of this is 10. Now it is magnitude 10, it is pointing towards x-axis. If I draw the same vector a bar 10 units but in opposite direction. Now direction so this is minus. Okay, so negative basically means opposite. Okay, now plus h1 g lang ako minus h1 v lang ako de. So it should be opposite. Okay, so negative vector basically means opposite vector. Okay, so suppose I ask you, I have a vector a. Okay, so a, I have a vector b. So this is 120. So if I ask you what is the angle between a and minus b. So if I ask you what is the angle between a and minus b, a to value a to so no change. A have b so now they ask you minus b. Okay, so where is minus b? So if this is a, then this will be minus b. Okay, opposite direction. So now you can see that the angle between these two is 120. Okay, so moving on. So next you have unit vector. Okay, so what is a unit vector? A vector whose magnitude is 1. Okay, magnitude is 1, unity. Okay, if any vector that has magnitude 1, so that vector is a unit vector. So any vector, any unit vector can be expressed as now it is a unit vector. So I will write here a cap. Okay, we call this cap. Assume to cap. So this is equals to a vector a bar divided by mod of a bar. So the vector divided by its magnitude. Okay, so any unit vector can be represented like this. A cap equals to a bar divided by mod of a bar. Okay, don't worry too much. Okay, you will understand. And then one more thing. X, Y to Z. If I have a unit vector pointing along the positive x-axis, okay, if I have a unit vector which is pointing towards x-axis, so we represent that vector by something called I cap. Okay, there is a cap. Cap means unit vector. So if I have a vector, unit vector pointing towards positive y-axis, so that is represented by z cap. Okay, and if I have a unit vector pointing towards the positive z-axis, that is represented by k cap. Okay, so what is I cap? A unit vector along plus x-axis, x direction. Okay, so what is z cap? It is a unit vector, so along plus y direction. Okay, so what is k cap? A unit vector along plus z. So you remember it like that. Okay, so I cap, z cap, and k cap. So I think those are the fundamental basic terms in vectors. So now let's go into addition of vectors. Okay, addition of vectors. So mainly you have two laws, right? So the first one is called triangular law of vector addition. So what is that law? You just see here. So if I have a vector A, okay, I have a vector B, then this is A plus B. Apetan paso relation. So this is A, this is B, this is A plus B. Okay, so if I have, you see here, if I have A, okay, if I have B, so tell me what is this? So this will be B minus A. Okay, so using this law, why B minus A? So you see, chilai chi dan pahe, A cho chilai chi abana so zompe pe B na zompe pe na, koti le chon hilai pada ong thak pada le A plus B. So you see here, I have A, okay, and then this. Okay, so that means if I add this and this, I have to get this one. Okay, using triangular law. So you can check here. So A plus B minus A. So how much will you have? A plus B minus A. A gets cancelled out, you'll have B. Okay, so it is true. It satisfies triangular law. Okay, so simply remember, if I have one vector like this, if I have another vector like this, then this will be the sum of this and this. So the second law is the parallelogram law of vector addition. Okay, so what is this? So if I have a vector A, okay, I have another vector B, then the resultant of these two, so the sum of these two vectors will be along this. So this is A plus B. So if you join this, you'll get a parallelogram. This is why it is known as parallelogram law of vector addition. Okay, so if you have one vector like this, another vector like this, then the resultant will be in between them, a plus b. So here important thing is what is the magnitude of this resultant vector. So I know that a plus b is the resultant. How do you find the magnitude of this resultant? Okay, so that will be given by magnitude of a square plus magnitude of b square plus 2 into magnitude of a into magnitude of b into cos theta under root. Okay, so what is theta here? Theta is the angle between a and b. Azo langa angle holdan isim da usulena. Okay, so this is the formula, and it is very, very important. Okay, so a plus b magnitude is a square plus b square plus 2ab cos theta, where theta is the angle between a and b. Okay, and one more thing here. So if I take this angle as alpha, yeah, so this part, okay, if I take this as alpha, I have one more formula, so that is tan alpha. Okay, so this will be given by vector mode of magnitude of b into sine theta divided by magnitude of a plus magnitude of b into cos theta. Okay, sometimes may be useful. Okay, so remember it like this. Okay, so the vector addition a주 law nium na triangular law to parallelogram law chiteni jana. So this one is important. Okay, so next you have a product of vectors. Product azong hi nium na, so you have two products. So the first one we call as a dot product. The second one we call as cross product. Na amin jong that's like amin dang khat jong na dot product pa hi bigitiam tele, it is also called scalar product. Okay, and cross product is also known as vector product. Yeah. Okay, so first let's see what is a dot product. Let's using the formula. So if I have two vectors a and b, right? So the dot product of a and b will be, so a bar dot b bar will be equals to magnitude of a into magnitude of b into cos theta. Okay, this is the formula. A b cos theta. 네, 그들 cross product 가지고 a cross b is equals to mod a mod b sin theta. Okay, so like theta है हम angle between a vector and b vector. Okay, so the same thing. So theta is the angle between a vector and b vector. So a dot b is ab cos theta, a cross b is ab sin theta. Okay, let's practice it. Nah? So example, suppose I have a vector a bar. So the magnitude of a bar is, let's say, equals to 3. Okay, I have another vector b bar. So let's say the magnitude of b bar is 4. So angle between them is so let's say how much? 60. Okay, 60 degree. So find out number 1 a dot b, number 2 a cross b. Okay, 그때 formula direct apply le chun jan pod ha chipen hi magnitude of a into, okay, I'll write here a dot b is equals to magnitude of a into magnitude of b into cos theta. Nah, magnitude of a to 3, magnitude of b to 4 into cos angle between them to 60 degree. So 3 4 are 12, cos 60 to 1 by 2, so I will have 6. Okay, a dot b is 6. Nah. So similarly you find out a cross b. So what is a cross b? So a cross b is a into mod b into sin theta. Yeah. So that is nothing but 3 into 4 into sine 60. Angle between them is 60. Go to that 12 into sine 60 is root 3 by 2. Yeah. So this is nothing but 6 root 3. Okay. So that is the answer. Nah. So remember the formula. Okay, so this much is an ibolotin. Abanaku, you have a component of vectors, you have position vector, you have displacement vector. Okay, 3 topics are left. So that one I will cover in the other video, part 2 of this vectors topic. Okay, so we'll end up here. Hope you understand. See you in the second part of the video. Okay, thank you.